All right. Right. A set can be defined. Set can be defined. Set can be defined. Set can be defined as a well-defined collection. Well-defined. Well, yes, well-defined. Well-defined collection of an object. Well-defined collection of an object. Yes. Set can be defined as what? Well-defined collection of an object. It's not connection, it's collect. Collection of an object. Full stop. Full stop. So, in like literal meaning, no, right? When you are talking about set, it's also a particular data. Set is a data. You get, but you know that you have different type of data. You might collect data in a random way. You get, and you might collect data in a district way. You get, so we have district data, we have random data. So the random data, it means all the data you are collecting, they are not well defined. You get, they are not well specified. But when you are talking about sets, this one is different from random data. It's a data that is well collected, well defined. You understand? So that's difference between other data and what? Sets as a data. You get? Because if you are doing statistics, you will still be doing all these sets in statistics. You get? So you know that okay, this particular set is what? Is a data. Full stop. In set theory, comma. In set theory, comma. A bracket called, you all know the bracket now, called what? Curly bracket. A bracket called what? Curly bracket. A bracket called curly bracket is always used. A bracket called what? Curly bracket is always used. So when you are dealing with sets, you don't just use any what? Bracket. You don't use square bracket. You don't use parentheses. You get? You use what? The curly bracket, which is this. Something like this. This is what we call curly brackets. Are you following? Full stop. Each datum in a curly bracket, each datum in a curly bracket is called an element or member. Is called an element or what? Member. Is called an element or member. So we always use E to denote elements. It's called an element or member. Full stop. Full stop. It's called an element or member. It's called an element or member. Full stop. For example, so A, you can say A is an element of what? Of X. Mathematical notation. B is also an element of what? X. But E is not an element of what? Of X. So when you are talking about non-elements, that non-member, after you write the element, you just put the what? A stroke line. Do you get that? Please, are you following? Okay. Full stop. Full stop. So this is just the brief introduction to sets. You know, mathematics, you don't really need much stories, right? But this is just the brief introduction that you need to know. At least you must know that this is the definition of sets. in a set, we use curly brackets. Each element, each datum in what in a set is called what? Element or member. These are just the brief introduction you need to know. And how do you denote your elements if they ask you anything about that? So subheading: types of sets. Types of sets. Yes, please, there are some definitions I will be giving you. Those definitions, they always bring them out indirectly, especially when you reach the definition of union sets, universal sets, all those things. Those definitions like this, please note them very well. They always ask, but they don't ask them in theoretical form like in English word. You just bring them in mathematical notation. You understand? So number one, types of sets, right? Number one, superset is not types of sets. Number one, we have singleton sets. Singleton. We have singleton. This is also called unit sets. This is also called what? Unit set. This is also called unit set, and it's a set. And it is a set in which, and it is a set in which only one member is present. Only one member or one element. Anyhow, only one member or one element is what? Is present. Full stop. So e.g., just have a set like this. It's a type of what? A singleton. So most of the time, you always hear unit sets. But when you are giving options, you might not see unit sets. You might see singleton there. Do you get that? You know that singleton sets also called what? Unit sets. So the set whereby you're having only what? One member. Number two, empty set. Empty set. This is also called what? Null set or what? It's also called null set or void set. Yeah. It's also called null set or what? Void set. And the set in which no member is present. The set in which what? No member is present. So you just use this symbol like this, or you always use this symbol. This symbol is called what? Phi. So this is phi in mathematics. So you can use empty set like this, or you use what? Phi. This is called phi in mathematics. Phi. Note MB. This is not an empty set. You get? This is not an what? Empty set. This is a set itself. It's not an empty set. Full stop. Number two. Number three, right? Equal set. Equal set. Two or more sets are said to be equal. Two or more sets are said to be equal. Two or more sets. Two or more. Sets are said to be equal if the number of elements are said, S-A-I-D. Two or more sets are said to be equal if the number of elements in the first set, if the number of elements in the first set is equal to the number of elements in the second set, if the number of elements in the first set is equal to the number of what? Elements in the second set. Full stop. Where arrangement does not matter. Where what? Arrangement does not matter. So this is what we are saying. You are having set A to be A, B, C, D, and set B to be D, C, D, A. You get? You can see that. What are you having here? You are having A, B, C, D. You are having D, C, B, A, right? You can see that the elements that you are having in A are also present in what? In B. That's the meaning of equal set. Not just that, because sometimes you might have A, B, C, D, might have another set E, F, G, H. They now ask you, are they equal? No. The meaning of equality is that the elements that are present in what? In A are also present in what? B. But the arrangement does not concern you. If you are having 1, 2, 3, 4 here, and they bring 4, 3, 2, 1. So what that you are having 1 in A, 1 in B, 2 in A, 2 in B, 3 in A, 3 in B, 4 in A, 4 in what? B. They are what? They are equal. So how many elements are you now having here? You are having 4. How many elements are you now having here? You are having 4. So these are the two things you use to determine the equality of set. The first thing, the members that you are having in what? In A must also be present in what? In B. Second thing is that the number of members must in A must also be equal to the number of members in what? In B. Do you get that? Aha. So therefore you can say set A is equal to what? Set B. Are you following? The next one, disjoint set.